Hello, welcome back. In this video, we'll discuss the conductivity of liquid electrolyte solutions. The liquid electrolyte solutions have high ionic conductivity. The high ionic conductivity originates from the fact that certain substances can dissociate in liquid solvents. This is mainly due to the dissociation of the substance in liquid solvents. And when a substance is dissociated in a liquid solvent, it produces the solvated anions and cations. The dissociated substance will produce solvated anions and cations in the liquid solvents. The mobility of these anions and cations, they contribute to the ionic conductivity, or the resulting ionic conductivity in a liquid electrolyte solution is due to the mobility of these anions and cations. We shall now see how sulfuric acid, that is H2SO4, dissociates in water. It dissociates in water according to the following scheme. H2SO4 gives rise to H plus HSO4 minus, and HSO4 minus dissociates as H plus SO4 minus 2. So this is the dissociation scheme of sulfuric acid in water. To improve the ionic conductivity, one can increase the concentration of the aqueous solution by adding more sulfuric acid to the water. And this is a critical electrolyte that is used in batteries. The high ionic conductivity of such aqueous solutions contribute to the overall success of these devices. The mass transport of ions in liquids is much more compared to the solids. One can vary the ionic conductivity by merely changing the concentration of the dissociating species. In this case, the dissociating species is the H2SO4. However, it's not possible to continuously increase the ionic conductivity of aqueous solution of H2SO4 by increasing the concentration of the sulfuric acid in water. Along the x direction, we are plotting the concentration, and along the y direction, we are plotting the specific conductivity. As we increase the concentration of H2SO4 in water, we find that the specific conductivity increases sharply, and for some concentration of the H2SO4, it reaches a maximum value. Beyond that, even if you increase the H2SO4 concentration, we notice that the specific conductivity is not increased further, rather it decreases slowly. For higher concentration of H2SO4, beyond this concentration, one finds a lower specific conductivity for the solution. This diagram represents a schematic dependence of the ionic conductivity of aqueous solutions of sulfuric acid on its concentration in water. Why such a thing happens? Because there is not enough solvent to make all the molecules dissociate fully. So there is not enough solvent to dissociate all the molecules. Therefore, the number of ions responsible for the conductivity and the conductivity itself decreases. The conductivity of liquid electrolytes often increases with the increase of temperature. However, it is often difficult to predict such dependencies, as many other parameters, for instance the dielectric constant associated with the solvent, plays an important role in the conductivity. Here we are plotting temperature along the x direction, conductivity along the y direction. This plot corresponds to the conductivity of 0.01 m aqueous solution of KCl. KCl is dissolved in water. So when the temperature is increased, we notice that the conductivity is increasing almost linearly. Whereas the dielectric constant of pure water, as a function of temperature, if you try to plot, along the x direction the temperature, along the y direction the dielectric constant, then we notice that the dielectric constant slowly decreases. The ionic conductivity increases with temperature and the dielectric constant decreases with temperature. The decrease in the dielectric constant will give rise to changing polarizability. Therefore, the solvent's ability to solvated anions and cations decreases. Thereby, the conductivity is affected. In this video, we have seen the conductivity of liquid electrolyte solutions. We have said that the liquid electrolytes have high ionic conductivity. The high ionic conductivity is mainly due to the dissociation of the substance in the liquid solvents. The solvated anions and cations and their mobility is responsible for the ionic conductivity. We have seen how H2SO4 dissociates in water. We have seen the effect of concentration on the specific conductivity in the case of H2SO4 in water. We have said that with the concentration, the specific conductivity increases up to a point, and beyond that point, even if you increase the concentration of H2SO4 in water, the specific conductivity slowly decreases. We have seen a mechanism to explain the changes in the conductivity. We have said there is not enough solvent to dissociate all the H2SO4 molecules in the solvent. We have also seen how temperature affects the ionic conductivity. In an aqueous solution of KCl, with the temperature, the ionic conductivity increases almost linearly, while the dielectric constant of water decreases almost linearly. So the combined effect would give rise to the conductivity of aqueous solution of KCl at any given temperature. Thank you.